The next phase of Starship development is upon us, and it's nothing short of exciting. We're seeing advancements across the board: new Starship versions, refined production techniques, upgraded test systems, innovative launch processes, and so much more. Yet amidst all this progress, one crucial system remains somewhat enigmatic: Raptor 3. What upgrades are being made to this powerful engine? When will it be implemented? Elon Musk has dropped some intriguing hints, making bold statements that have left scientists buzzing with anticipation. Let's dive into the details and uncover the latest updates on today's episode of Great SpaceX. The final month of the year has arrived, and SpaceX is already gearing up for the next major milestone. While the next Starship flight is projected for early next year, 2023 has been a remarkable year for SpaceX's development journey. 2024 has been a remarkable year for SpaceX's development journey. With 4 Starship flights completed, the company has made significant strides in validating the performance and reliability of its Raptor engines. From smooth activations and shutdowns to precise navigation, acceleration, and deceleration, the Raptors have demonstrated their capabilities with remarkable consistency. One of the year's most notable achievements was Booster 12's successful landing using the innovative Mechazilla arms, a feat that showcased the potential of SpaceX's unique recovery systems. However, achieving reliability with the Raptor engine is far from SpaceX's ultimate goal. The company's ambitions stretch far beyond, as evidenced by the unveiling of Starship V2 and the ongoing development of Raptor 3. Dubbed by Elon Musk as a work of art, the Raptor 3 engine is poised to redefine what is possible in rocket propulsion. Since its introduction in August, Raptor 3 has been a topic of great excitement and anticipation. Musk recently described the engine as truly sublime engineering, adding that its capabilities are so advanced that even seasoned veterans of the space industry initially deemed them impossible. One of the most thrilling aspects of Raptor 3 is its enhanced thrust capability, which Musk detailed in a recent update. According to Musk, Raptor 3 aims to deliver an incredible 300 tons of thrust per engine at liftoff. With 33 engines powering Starship's first stage, this translates to nearly 10,000 tons of combined thrust, approximately 3 times the power of NASA's legendary Saturn V rocket. To put this into perspective, Raptor 3 was already impressive with a maximum thrust of 269 tons, and SpaceX initially announced Raptor 3 would reach 280 tons. However, Musk's revelation of a 300-ton capability pushes the boundaries even further. This increase in thrust is not just a marginal improvement, it has profound implications for Starship's performance. The new thrust levels bring Starship closer to achieving its goal of transporting larger payloads to orbit and beyond, including missions to the Moon and Mars. Additionally, with Musk hinting at future engine versions capable of delivering 330 tons of thrust, it's clear that SpaceX's long-term vision includes even more powerful and efficient propulsion systems. While thrust is a critical metric, it's only one piece of the puzzle. A truly revolutionary engine must also excel in efficiency, reliability, and manufacturability. Raptor 3 is designed with these priorities in mind. Musk highlighted the extraordinary effort required to simplify the engine's design. The amount of work required to simplify the Raptor engine, internalize secondary flow paths, and add regenerative cooling for exposed components was staggering. This simplification process represents a major leap forward in rocket engine design, as it reduces complexity while enhancing performance. A key aspect of Raptor 3's simplicity is the removal of flanges and screws, which are traditionally prone to issues like leaks and heat accumulation. These components have been replaced with welded structures which are more robust and reliable. Additionally, the integration of systems has enabled the removal of the engine heat shield, resulting in significant weight savings. To compensate, Raptor 3 features an advanced regenerative cooling system that protects the engine from the intense heat and pressure of operation. These design changes not only improve performance but also make production more efficient. With Raptor 2, SpaceX reached a production rate of 1 engine per day, a remarkable achievement in its own right. The simplified Raptor 3 design could enable even faster production rates, especially with the integration of advanced 3D printing technologies. Faster production reduces costs and ensures a steady supply of engines to support SpaceX's ambitious launch schedule. Simplicity also brings benefits to post-launch operations. A less complex engine is easier to refurbish, reducing turnaround times and enabling the high-frequency launches required for Starship's reusability goals. This aligns with SpaceX's broader strategy of lowering costs and increasing accessibility to space. Despite its potential, the big question on everyone's mind is when will Raptor 3 make its operational debut? During the Flight 6 launch, Musk suggested that Raptor 3 would be introduced sometime in 2025.
A big version of the increase that'll be flying next year.
However, details about its production progress remain limited, leaving room for speculation. Many observers initially believed that Raptor 3 would debut with Starship V2 starting with Ship 33 on Flight 7. However, SpaceX opted to equip the first V2 prototype with Raptor 2 engines, indicating that Raptor 3 was not yet ready for flight. Looking ahead, it seems unlikely that Raptor 3 will appear in the next few flights. SpaceX's upcoming missions include critical milestones, such as the catching of the Starship upper stage with the Mechazilla arms. For such high-stakes operations, SpaceX may prioritize the proven reliability of Raptor 2. As a result, Raptor 3 might not make its debut until after these missions are successfully completed. Based on current timelines, a realistic scenario for Raptor 3's debut could be around Flight 9. This would allow SpaceX to finalize production and conduct thorough testing before integrating the new engines into an operational mission. Of course, SpaceX is known for its rapid development pace, so the timeline could shift depending on progress. Whenever it arrives, Raptor 3 is set to be a game changer. Its combination of increased thrust, simplified design, and enhanced reliability will enable Starship to push the boundaries of space exploration. From delivering cargo and crew to the Moon and Mars to supporting the construction of a multiplanetary civilization, the potential applications of this engine are virtually limitless. As we anticipate Raptor 3's debut, it's a perfect time to reflect on SpaceX's journey. Their iterative approach, refining each version through testing, has driven progress from Raptor 1 to Raptor 2 and now to Raptor 3. Each iteration represents leaps in performance, cost efficiency, and manufacturability. Raptor 3 marks a pivotal moment for SpaceX and the future of space exploration. With nearly 10,000 tons of thrust, groundbreaking efficiency, and a streamlined design, this engine isn't just a technological achievement, it embodies humanity's limitless potential when innovation and ambition unite. Get ready to witness history, share your excitement, follow for updates, and join SpaceX as they push the boundaries of what's possible. The future is here, and Raptor 3 is leading the way. But of course, the introduction of Raptor 3 is merely the opening chapter in the next era of SpaceX's Starship program. As SpaceX pushes the boundaries of rocket design and performance, Musk has ambitious plans for future iterations. The goal is to increase the thrust of the Raptor engine to an astonishing 330 tons, resulting in a total liftoff thrust exceeding 10,000 tons. Such a feat would establish this as the most powerful rocket ever developed. While specific design details for these more advanced engines remained undisclosed, it is anticipated that they will maintain SpaceX's trend of simplifying and optimizing their designs. According to plans outlined in the Starship Florida project, these upgrades are likely to coincide with Starship V3, a version projected to stand an impressive 150 meters tall. This iteration could become the cornerstone of SpaceX's Mars missions, which Elon Musk has optimistically suggested may commence within the next 2 years. And achievements, inviting us all to imagine what lies ahead in this grand adventure. Turning to recent developments in the global space race, China's land space achieved a significant milestone with the launch of its upgraded Zhuque-2E rocket. The launch occurred at 9 p.m. Eastern from the Dongfeng Commercial Space Innovation Test Area at the Jiuquan Satellite Launch Center. This mission successfully deployed 2 Guangquan satellites into orbit, marking a major success for the company. The Zhuque-2E is an advanced version of Landspace's methane-powered rocket. Measuring 47.3 meters in length and 3.35 meters in diameter, it boasts a payload capacity of 4 tons to sun-synchronous orbit at 500 kilometers. The Zhuque-2 program had a challenging start with a failed debut in December of 2022. However, the subsequent 2 missions were successful, making the Zhuque-2 the first methane-fueled rocket to reach orbit and deliver a payload. This progress positions Landspace as a leader among Chinese private aerospace companies, particularly those often labeled as SpaceX copycats. The company plans another Zhuque-2E mission in December and is already setting its sights on the Zhuque-3, a stainless steel reusable rocket resembling SpaceX's Starship. Landspace conducted a test flight for Zhuque-3's launch and landing system in September, with a full launch anticipated by 2025. Despite its strides, Landspace's achievements do not yet rival SpaceX's Starship. While the Zhuque-2 earned the title of the first methane rocket to reach orbit, Starship has already moved far beyond, achieving orbit, controlled landings, and recovery of its super heavy booster. With ongoing advancements, such as mastering two-stage landings using the Mechazilla system, Starship continues to set a standard unmatched by competitors. The methane rocket sector, however, is heating up. In addition to Zhuque-2 and Starship, other players are entering the fray, including the Blue Origin, New Glenn, and the ULA Vulcan Centaur. This competition promises an exciting race to establish dominance in this emerging rocket class. Who will lead the charge? For now, SpaceX remains far ahead, but the coming years will undoubtedly reveal the next chapter in this dynamic field. Starship is continuously evolving, becoming bigger and more powerful over time. To create such giants, many aspects of its design and construction have changed, particularly the welding methods used in its assembly. With new versions on the horizon, including the highly anticipated V3, it's a great time to look back at the evolution of these welding techniques and explore what upgrades we might expect in the upcoming version. So how have these welding methods progressed, and how will they continue to evolve alongside Starship's development? The massive Starship rocket, a symbol of SpaceX's vision for interplanetary travel, is not a monolithic structure, but rather composed of meticulously assembled stainless steel rings. These rings are welded together into segments and then stacked using advanced welding techniques. While welding might seem like a straightforward process, its execution is anything but simple, requiring precise methods and careful attention to detail. Elon Musk has often highlighted the critical importance of welding in the construction of Starships, stating, "A lot of ways to melt and join steel, mostly just needs to be welded consistently and with precise parts." This precision becomes even more vital when using stainless steel instead of the carbon fiber utilized in Falcon rockets. Stainless steel offers several advantages, including lower cost, greater durability, and versatility in shaping. However, it also presents challenges, particularly in its tendency to retain heat, which can complicate the welding process. In the early stages of Starship development, SpaceX employed the flux-cored arc welding method, or FCAW. While functional, this approach had its limitations. Early Starship prototypes appeared rough and unsophisticated, with visible welding seams and traces. The high heat generated by FCAW caused the stainless steel to warp and deform, resulting in an uneven surface. Additionally, stainless steel is prone to scratching, making it impossible to grind down the weld marks for a smoother finish. These issues were not merely aesthetic, they posed real structural risks. Imperfect welds could lead to cracking during the rocket's operation, particularly during the intense stress of atmospheric re-entry. Such vulnerabilities could compromise the integrity of the weld and jeopardize missions. Recognizing these shortcomings, SpaceX transitioned to a more advanced welding method called TIG-TIP, or TIG-tip semi-automatic welding. This technique provided significantly greater control over the welding process, resulting in cleaner, more uniform seams. Musk himself highlighted the benefits, explaining, "These parts are stamped versus manually bumped formed and TIG-tip welded versus flux core. Higher precision, stronger joints, and 20% mass reduction." The advantages of TIG-tip welding extended beyond aesthetics. The method produced stronger welds, reducing operational risks and allowing for thinner stainless steel rings. With fewer welds required, Starship's overall mass decreased by up to 20%, a critical improvement for a spacecraft designed to carry large payloads and traverse extreme environments. SpaceX didn't stop there. They continued to enhance their manufacturing processes by introducing laser welding machines. These automated systems significantly increased precision, further improving the strength and appearance of the Starship prototypes. This progression is especially evident when comparing the nose cones of early prototypes with those of more recent iterations. The newer prototypes boast a sleek, polished look, free of visible weld marks while benefiting from faster and more efficient production cycles. Another crucial upgrade in Starship's evolution was the transition from 301 stainless steel to 304L stainless steel. This newer alloy offered improved corrosion resistance, a critical factor for both manufacturing and operation in space's harsh conditions. The enhanced composition of 304L made the welds up to 4 times stronger than before and increased the material's ductability by 25% at extreme temperatures. Additionally, its low carbon content helped to prevent cracking, further enhancing the rocket's reliability. These advancements represent a culmination of SpaceX's relentless pursuit of excellence. By refining their welding techniques and upgrading materials, SpaceX has transformed Starship into a spacecraft that is not only visually impressive, but also exceptionally strong and durable. The combination of precise welding, advanced materials, and automation has paved the way for a rocket capable of withstanding the demands of deep space exploration. Starship's journey from rough early prototypes to its current state is a testament to SpaceX's innovative spirit. Each improvement in welding methods and materials brings humanity closer to realizing the dream of sustainable space travel. Through these advancements, SpaceX continues to set new standards in aerospace manufacturing, proving that no detail is too small when building the future of interplanetary exploration. SpaceX is now taking the technologies and lessons learned from earlier versions of Starship and applying them to its new iterations, pushing the limits of innovation even further. Currently, SpaceX is in the process of producing Starship V2, incorporating several design changes and laying the groundwork for the upcoming V3, a colossal version anticipated to reach a towering height of 150 meters. In these new versions, durability remains the top priority. As Starship aims to venture deeper into space rather than just reaching orbit like V1, it will face increasingly harsh conditions. Re-entry processes in particular will expose the ship to extreme temperatures, demanding robust design and materials. After 6 flights, Starship V1 has demonstrated steady improvements, especially in handling the challenges of re-entry. However, full recovery remains elusive, highlighting the need for further advancements in production methods. Encouragingly, the early prototypes of V2 exhibit notable enhancements. A side-by-side comparison of the nose cones from V1 and V2 reveals a significant upgrade. The welds on V2 are practically invisible, giving the impression of a seamless single block. This not only suggests improved durability, but also highlights advancements in welding technology. But durability is just one part of the equation. SpaceX is also focused on reusability, striving to ensure their rockets can perform multiple flights. Enhanced welding methods will play a crucial role in achieving this, as they reduce structural stress and streamline refurbishment processes. Another critical advantage of the new welding methods is speed. With significantly increased automation, production times have seen a dramatic boost. The first prototype of V2, Ship 33, was built in just 42 days, a testament to SpaceX's commitment to efficiency. However, the true effectiveness of the V2 welding techniques will be tested in actual flights, beginning with Flight 7 early next year. These flights will provide essential data for further refinements, paving the way for the development of V3. Once the welding and production principles stabilize, SpaceX's next step will be replication on a larger scale. That's where Star Factory comes in. It's already operational, producing parts continuously. To meet the demands of mass production, additional welding systems may be needed, alongside expanded facilities like the planned Gigabay. This new assembly bay will be taller and wider, capable of accommodating the larger Starship versions down the pipeline. Regarding deployment schedules, SpaceX has ambitious plans for both Starbase and its Florida facilities, which are expected to utilize V3 versions. NASA has stated that Starship will move to Florida operations once it achieves a cadence of 1 launch per week, a milestone likely to occur early next year. To meet these goals, preparations for the production system, including welding technologies, are essential and must be addressed now. SpaceX's ultimate vision is to produce 1 Starship per day, necessitating round-the-clock operation. Continuous advancements in welding and overall production methods will be critical to achieving this target. Beyond production, SpaceX is enhancing its testing and launch systems to complement its manufacturing capabilities. The Flame Trench test system, already operational, has proven highly effective. This innovation allows SpaceX to increase its launch rate, with newer prototypes often ready before previous versions have ever flown. Significant upgrades are underway at the launch site, including the addition of Launch Tower B and a new orbital launch mount. These systems are key to increasing Starship launch frequency and eventually catching the rocket. They are expected to be replicated as Starbase expands and new launch facilities like those in Florida are established. SpaceX is building an unprecedented system that integrates advanced production, rigorous testing, and cutting-edge launch capabilities. Every detail, no matter how small, supports the broader vision. One day, Starship will take humanity to the moon and Mars, achieving what once seemed impossible. These milestones will rest on countless smaller innovations, such as improved welding techniques that strengthen its foundation. What do you think of SpaceX's Starship development, especially the evolution of its welding methods? Share your thoughts in the comment section down below, and don't forget to like and subscribe for updates on SpaceX's incredible journey. Wrapping up that whole segment with Starship, let's shift our focus to an exciting update on Varda Space Industries and their recent milestone, a significant $48 million contract awarded by the U.S. Air Force Research Laboratory, otherwise known as AFRL. Varda Space Industries is well recognized for its innovative work in developing and operating re-entry capsules designed to return specialized cargo from space. Earlier this year, in February, Varda successfully completed its first mission, W-1. This mission marked a groundbreaking achievement, the safe return of a capsule carrying pharmaceuticals created in a microgravity environment. The capsule re-entered Earth's atmosphere at a blistering 18,000 miles per hour, or around 29,000 kilometers per hour, and executed a precise landing in the Utah desert using a parachute system. Building on this success, the AFRL contract underscores the increasing interest in commercial re-entry vehicles for cutting-edge military applications. This partnership specifically aims to test military payloads at hypersonic speeds, a notoriously complex challenge in aerospace engineering. Hypersonic testing involves navigating extreme thermal protection, maintaining accurate navigation, and ensuring reliable sensor performance, all critical components for the next generation of defense technology. The collaboration is also a cost-effective solution for the U.S. Space Force, as it provides a controlled, real-world testing environment without the steep expenses associated with traditional hypersonic vehicles. Varda's expertise in capsule design and hypersonic re-entry positions them as an ideal partner for this initiative. Under its new contract, Varda is set to launch its W-2 mission in early 2025, featuring the Varda Hypersonic Test Bed Vehicle with the AFRL's Osprey spectrometer payload. Osprey will collect vital atmospheric data during high-speed re-entry, advancing science and defense technologies. This collaboration highlights the growing potential of commercial military partnerships in space innovation. Stay tuned as Varda pushes the boundaries and refines its cutting-edge systems. In any case, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.